Hey everyone, I'm Sarvan Rangarajan. I'm a senior product manager on the Amazon Elastic Container Service team, and I'm here today to talk to you about getting up and running with Amazon ECS. So first, I'm going to go over exactly what is Amazon ECS, what are the benefits that it provides, what is everything that it has to offer. I'm going to walk through step by step exactly how you take an application and get it up and running on the Amazon ECS service. Go over some of the developer tools that allow you to do that in a very easy manner. I'm actually also going to show you a demo of what this is like firsthand and how to get up and running in minutes. And finally, just summarize everything that we went over today. So Amazon ECS, what is it? What does it give you? What exactly does it do? So the main thing is it is a container orchestrator as a service. You only need to interact with Amazon ECS just through various APIs. You don't even need to log into an EC2 instance. The service itself will make sure that any of your containers that you've packaged your applications into are up and running across EC2 instances or instances managed by us, and scaled appropriately. If an instance goes down, Amazon ECS makes sure another one comes back up so that your containers are up and running and can accept traffic. Amazon ECS is also very flexible in terms of how you can schedule workloads and the types of workloads that we offer and how workloads are placed on the various instances. We have customers that use a variety of types of applications, from web applications to batch jobs to multiplayer online gaming to machine learning inference jobs. It's a wide spectrum. Amazon ECS can be used for things that need to be long running and need to be up and running always, or it can just be used for things that just need to do one task and then just be completed. With Amazon ECS, you can leverage Amazon load balancers such as Elastic load balancers, application load balancers, network load balancers, service discovery through AWS Cloud Map. So Amazon ECS lets your microservices that are packaged as containers talk to one another. Same with AWS App Mesh. Your containers can actually write data to external storage through Amazon Elastic File System. You can set up a full enterprise-grade deployment pipeline through AWS Code Deploy and Code Pipeline and Code Suite. And then finally, in order to make sure that all of your containers are up and running and working as expected, you can use Amazon CloudWatch to see performance metrics of your containers, of the applications inside them, and also telemetry and logs that are being written by your workloads. Amazon ECS is also very extensible. So not only can you use your own scheduler, Amazon ECS has a built-in scheduler with how your containers are distributed across your container instances, but you can also wire in your own with our flexible APIs. And the ECS agent, which is actually the software that runs on the instances themselves and makes sure that your containers on the instances are running and healthy. That agent is open source, and we accept pull requests from external contributors all the time. And you're welcome to go and contribute new features or even just see exactly how it works. In addition to the open source agent, Amazon ECS has a wide variety of integrated partners, such as through GitHub Actions, where you can do automated GitOps deployments, through Datadog and Dynatrace and New Relic, where you can monitor and observe your workloads by installing their software on your EC2 instances that Amazon ECS uses. The number of partners, it just grows every day, and I recommend you checking out the list on our website. Also, one of my favorite benefits is Amazon ECS is just secure by default. All the resources you create, from the containers you launch to the EC2 instances, are all within your own VPC by default and blocked off from external traffic unless you choose to open it. And this is either for the EC2 instances that you own or for EC2 instances that are managed by AWS. So you might be asking, managed by AWS, like what exactly does that mean? So that actually leads into my favorite benefit of Amazon ECS is that we have a serverless variant called AWS Fargate, where you as a developer, if you just want to deploy your applications as a container and not have to worry about the EC2 instances that they land on, including choosing the right size for them, the right instance type, making sure that there's enough capacity in those instances for all your containers, making sure that you have enough instances themselves, not only just the size, but also the number of instances, all of that stuff, and even like operating system updates and patching. ECS will just handle all of that for you if you use AWS Fargate. The only things you really need to think about when you use Fargate are just your application itself in the container and exactly how much CPU and memory or resources your container is actually going to use. So that's a really cool part of ECS where it's really application first and developer centric. That you only have to worry about your application and you're even build just based on what that container uses, not what the EC2 instances use. So that's all great. Tons of benefits of ECS and how it orchestrates containers for you. But how exactly do you get started? Like what do you need to do if you have an application you want to get up and running? So the first thing you do is, of course, you need to write the code of your application and then make sure that you publish that to a centralized place where you and your friends or your teammates or other members of your organization can collaborate. So you can use a source control like GitHub or code commit in order to do this. That way, all of you can contribute to the same code base and be more productive. So once you actually have your application in your GitHub or in a GitHub repo or in some repository, and you also have authored a Docker file which tells which actually just dictates how your application should be built when it's packaged into a container, you're ready to move on to the build stage. So with the build stage, your application plus that Docker file is packaged into what's called a container image. You can think of an image as kind of like a blueprint. And from that blueprint, multiple containers are going to be built or started. So that image is then sent off and stored to what's called a container registry. Examples of that are Docker Hub or Amazon ECR. And in that registry, it can be it can be globally distributed so that when you have containers that need to start from that image, they can start up really fast. And yeah, then after you have your image in a registry, well, I guess it's actually time to deploy something. So to actually get started and get your containers up and running. So the next part is actually releasing and starting your containers on Amazon ECS. The terminology we use is called tasks, which is just a group of containers that work together. So from your registry, you can start Amazon ECS tasks, and then ECS will make sure that all of your tasks are up and running, and that if a task has to go down for some reason, that another one would be started up in its place. So once you have your workload up and running, that's great, but it's not the end of the journey. You need to make sure that everything is working as expected. And if an issue arrives, you need to be able to remediate it or maybe do another deployment or make another configuration change. And you can observe if these things are required through monitoring tools like Amazon CloudWatch or something like Datadog or Dynatrace or New Relic, etc. So those are the sequence of steps on how you actually go from code to actually something running and a production workload that you can observe. And it seems like there's 4 different things that you have to do, but we actually offer a variety of tools that let you accomplish this journey pretty straightforwardly. And the cool thing about our developer ecosystem is we offer the right tools for you as a persona or you as an organization, depending on what your interests are, what your needs are. So I personally, I'm a visual learner and I like to see things as I use them. So one of my favorite tools is actually just the AWS Management Console. So I can go into the AWS Management Console and click around and make sure that my container is started. or my tasks are started, my tasks can be scaled. I can actually also go into the CloudWatch console and I can see visual graphs of how much CPU and memory my containers are using and whether they're exceeding a certain acceptable threshold or I need to go back and change something. The cool thing about the console is just like CloudWatch, all the other AWS services have consoles, and you can go in there and actually visually see the resources that you would use to integrate with Amazon ECS. I'm also a developer by training, so I like to get involved in the code and in terminals and CLI. So another great tool that we have is called the AWS CoPilot CLI. And CoPilot I'm going to talk a little bit more about later in the presentation, but for now it's a single CLI that you can use to get up and running, and it'll actually create a full-blown production environment for you with all the settings, all the configuration done on your behalf by the CLI itself. So more on that in a bit. And finally, if you want a more automated approach where if you have a deployment or have like already a blueprint of infrastructure in your application that you want to get up and running and you want it to be repeatable, then infrastructure as code is the right tool set for you. So within that, we have, of course, CloudFormation, which everybody that uses AWS is familiar with. But we also have what's called the Amazon Cloud Development Kit, or the CDK. And the CDK is another level on top of infrastructure as code where you can define your ECS resources and other AWS resources, actually, with familiar programming languages of your choice, like Java or C# or even JavaScript. So the really cool thing about this is you can define your infrastructure in the same programming language as you would write your application code. And not only that, you can take all the benefits of object-oriented programming, like doing for loops or doing branches or even writing unit tests for your infrastructure. So now I'm going to talk a little bit more about the AWS CoPilot CLI. And the CoPilot CLI is the easiest way to get up and running, to get containers up and running on AWS using Fargate. So with CoPilot, we realized that a lot of customers that use ECS, they saw that we have something called a task and a task definition, which is how you describe your group of containers that are going to work together. We have clusters, which is just a logical grouping of your ECS resources, including your container instances and the tasks that get placed on them. There are also load balancers that need to be involved if you want your container to accept traffic from the internet. So there's actually a lot of AWS. If you want a production-ready environment, there are a lot of AWS resources that you need to account for, and you need to make sure that you can stitch them together. So with CoPilot, we decided to handle all of that heavy lifting for you. And we offer types of architecture instead of just types of raw AWS resources or terms for you to interact with. So let's say if you want to deploy a web service or web application or a backend service or a scheduled job, then those are options that are the types of architecture that are available for you in CoPilot, and we will set up all the infrastructure necessary to get that up and running. And I'll show what that looks like in a bit. So with CoPilot, the way you actually just interact with your application that will be on ECS is just through a very simple guided CLI experience that will ask you prompts of what type of workload, what type of architecture do you want to deploy, and you just fill it in. The really cool part about this is it's a CLI that's made to be used by humans and for humans. So that way, it like when you interact with the CLI, it just feels really natural and comfortable. And any changes that you need to make to your workload, you can do through a very simple interface called a manifest, which I'll also show. CoPilot also takes us to the next level and sets up a continuous delivery pipeline where you can have more of a GitOps flow. Anytime you make a change to your GitHub repository, the code pipeline resource that CoPilot sets up on your behalf would trigger, and it would make sure to do all of those 4 steps that I described earlier. It would package your container into an image. It would deploy that image to ECR. It would create tasks from that image as well. And then it would return back to you an endpoint. And as I said, also just getting up and running is only part of the journey. You need to make sure that your service that's up and running continues to stay up and running. And if you need to make changes, you need to be notified about that. So within CoPilot itself, you can also operate, and you can see logs, you can see status, you can see details about your services. And enough about what it actually is. Let's actually get right into it. Okay, so let's actually see what CoPilot looks like. So with just one command, you can actually get something up and running, CoPilot init. It's asking me if I have a service in this repo, if I want to deploy it as part of an application. An existing one, I said no. So let's do a new one. Called it web app. And here you can see that it offers me various types of patterns of the type of service that I want to deploy. So right now we have 3 patterns, and as I said, CoPilot is going to deploy all the infrastructure necessary to support that pattern. So I'm just going to deploy a web service right now, call it web service. And here, CoPilot now asks me, how do I want to build this application? I wanted to use an existing Docker file, but I could have also used another pre-built image. So what's happening right now? Behind the scenes, CoPilot actually uses a CloudFormation infrastructure as code so that all changes are repeatable and are tracked. So it's actually right now creating the CloudFormation template that will have a load balancer, a VPC, all the necessary subnets and security groups. It's also creating the ECS resources, including an ECS cluster. And also it'll be soon creating the Amazon ECR repository, and it'll actually build my application and deploy it to that repository. Here we go. So the infrastructure was created. It also created a manifest file, which I mentioned before. I'll also show you what that looks like. It asks me if I want to deploy a test environment. And yeah, I do want a new environment. So now it's actually going to take that CloudFormation template and deploy it, and all those resources are going to get created. So you can see here, VPCs being created. We're getting subnets, all the necessary configuration and settings. Like this is the best part, that I just did one command and then it gave me a few guided prompts, and now I'm actually getting my service from that I just had as code in this repository, and that's now being deployed to ECS. Let me actually show you what an existing application looks like. So I have one that's running. I just called it reinvent application. And in CoPilot, an application is a group of microservices. And here I'm also showing you a reinvent service. So with that one init command, CoPilot deployed one ECS task with a certain amount of CPU and memory. It even gave me an endpoint. It set up service discovery and a number of environment variables. Taking a look at the manifest, you can see some of the things that I entered through the guided prompts are here, such as the Docker file and the name of the service. It also includes the CPU and memory that CoPilot set by default, but I can override that. And you can see that it defaulted to one task. So this is fine if I just want to get my service up and running and to see if it works. But in order to have something viable for production, my service is going to get a lot of traffic, and I don't want to have to go in and actually update the number of tasks it runs. So CoPilot supports auto-scaling notation, where here I can say, here's my threshold of how many tasks I want. So from 1 to 10 tasks. And anytime the average CPU percentage is over 10%, I want you to scale up. So as I was saying, after the getting up and running part is just part of the journey, you need to make sure that the service is actually ready for production. So you can see here also, I just did one command, and the Docker build part was actually very straightforward because no code changes were required. So it didn't even need to build my application and publish it to ECR because the image is the same. Now it just updated that auto scaling information in the CloudFormation template and made sure to deploy that. And this should only just take a second here. But I mean, while this is going, as you can see, the interface to also not just get up and running for the first time, but to make subsequent updates to your application on CoPilot is also very straightforward with just one CLI command. Great, so we have something up. It actually gave me an endpoint too. So why don't we actually put this to the test? Let's hit this application. Let's hit this endpoint with some load. I'm using the Hey client, which is actually going to bombard this URL with tons of requests. And we're actually going to see this service scale up from one task to many. And also you will be able to see it through CloudWatch Container Insights. So this is one of those feature integrations that I spoke about earlier with the AWS ecosystem, that every single service, and actually anything that I deploy to ECS, I've configured my account to have metrics transmitted by default into Container Insights, and I get these dashboards out of the box. It's just like a one opt-in setting, and all of this data is available for me to see anytime. And I can see exactly from a service or even task granularity how much CPU, how much memory it's using. And the cool part about this is these are the metrics that my service is actually going to scale on. So, so now the Hey client is hitting my service with tons of requests. The graph that I showed you before, it's soon going to blow up. But let's while the requests are coming in, let's take a look at some of the other things that is in CoPilot here. So as I was saying, CoPilot uses CloudFormation behind the scenes. So with the package command, you can see exactly all the CloudFormation that it does. And you can even export that CloudFormation into a different file. So any resources that CoPilot didn't create for you on your behalf that you want to use, you can just take the CloudFormation and add those resources yourself, and then just use that CloudFormation template too. CoPilot also gives you a command to look at the logs of your service. So this links up and calls back to the service on ECS, and it brings you the most recent logs within the CLI itself. So this is really cool because in the operate phase that I mentioned before, one option is you could use the AWS console, like going to CloudWatch Container Insights to see metrics and also logs, or you can just use the CoPilot CLI to see the logs too. You can also tail the logs, so now we'll be able to see logs coming in live, and you can see here that the Hey client is sending tons of requests, and new requests are just continuously coming in. So also, let's take a look at, like, I added that auto-scaling information before. So even though from the manifest that looked really easy and simple, what exactly did it create behind the scenes? So here you can see here with the status command that you can see the number of tasks running. So it looks like the auto-scaling hasn't kicked in just quite yet. And you can see 2 alarms here. So what this is using is something called target tracking, where if the CPU hits a certain target and there are a number of data points within a specific period of time, then that alarm will go off. So the first alarm, you can see if it's above 10% for 3 minutes and there's 3 data points, then it's time to scale up. But if it's below 9% for 15 minutes, then it's time to scale down. And the reason why the scale down alarm is it takes a lot longer is because you want your service to be scaled up and handle any residue or remaining incoming increased traffic before you actually take time to scale down. All right, so let's see if the auto scaling has started to kick in yet. Doesn't appear. So why don't we go and check Container Insights. Let's hit refresh. Looks like it might start to be slowly going up. Let's check the the service one more time. Let's do the status command. Sometimes it takes a sec to hit the actual threshold, and then for the metrics and container insights. Oh, wait, look at that. So speak of the devil, you can see on the left side that an alarm went off. So I think that must be the scale up alarm. Let's go and check that right now. That's correct. So that alarm as of 22 seconds ago went off. So now what's going to happen is ECS is going to start scaling up, and you can see there that I have 1 out of 9 tasks that are currently running and 8 are pending. So the additional tasks are going to come up to start to take those additional requests that I had sent. So let's actually do another status command. Great. So now you can see tons of tasks there. And it's cool. Within CoPilot, you can just see all of this happening live, what state those tasks are in. And let's do that one more time. And some of these tasks would have already been started. So this is really neat that I just used CoPilot. I used one command to get up and running. And CoPilot itself set up all the infrastructure needed. It did the build, the deploy, and it lets me do the operate stages. The only thing I really need to worry about is the develop stage, making sure my application is developed and in a repository. And CoPilot helped me pilot my application into the cloud. So just to summarize what we've seen in this session today, Amazon ECS is Amazon's native managed container orchestrator. So you can interact with ECS just through simple APIs, using only those APIs or using any of the developer tools that I mentioned. You can make sure that your containers are going from your code base and actually up and running as a production service or in a production environment. And Amazon ECS integrates with a number of tools to let you operate those services. And those tools also, we offer a variety of options, and they're tailored specifically to what you prefer and your preferences, you and your organization. As I said, the console for visual thinkers like myself, or for developers that like terminals and like scripting, we offer the CoPilot CLI, or even the AWS CLI too. And also infrastructure as code using just CloudFormation, the AWS CDK, and also Terraform. You can use Terraform templates to deploy your environments to ECS too. CoPilot is the easiest way to get up and running. As you saw today, you can get up and running with minutes with just one CLI command, and then you can use just a handful of others to make sure that your service is up to date. There is also another session at reInvent that's going to dive a bit more into CoPilot and some of the more advanced features, like setting up that deployment pipeline that I spoke about. And Amazon ECS provides observability out of the box. Like, remember, this is really important with that last stage of getting up and running, the operate stage, to make sure that what you got up and running stays up and running. And ECS with Container Insights lets you actually see that. CoPilot creates alarms for you, and you can even create your own custom alarms with CloudWatch to make sure that you get notified if your service goes down or if you need to scale up. Here are a few resources where you can learn more. The Amazon ECS product page has a number of case studies and more information about some of the specific features that we offer. If you're interested in using CoPilot or want to learn more about CoPilot, you can check out our GitHub repository, and on there is a link to our Gitter community where you can reach out to myself and some of the developers and the members of the community. And also, I want to put in a plug for Containers on the Couch, which is a web series run by some of our developer advocates. And they've done a few episodes on CoPilot and on ECS, and actually just on a number of container technologies and features that have come out recently. So go to containersfromthecouch.com and search for CoPilot or search for ECS, and you can see those too. So hope you guys enjoyed the session today. I hope you learned something about ECS, CoPilot, or just what it means to get something up and running on ECS. And not just up and running, but actually operate and make sure that it's working as expected. Feel free to take the survey and leave your thoughts about what you thought and any feedback that you may have. And yeah, thanks. You can also follow me on Twitter at Shravan_R_. Thank you.